It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with a test
to bring out the best in you. Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Good morning, all of you. Good morning. Welcome, you guys. All of you, welcome. Yes, fine. The last class we have discussed about the Boolean algebra analysis. We have seen the NAND gate, NOR gate implementation, all the analysis we did. Yes. Now, in the today's class, we'll start. What will start today's class? In the today's class, we'll start the combinational circuits. Today's class will start the combinational circuits, isn't it? And the combinational circuits. You can just have a so look at now, all of you. Look at now here. That what we are going to deal here. You see the combination circuits we are dealing here. Combination logic circuits. So here we are going to see this thing as a adders, subtractors, binary multiplier, decoders, encoders, multiplexer, demultiplexer, priority encoder, code converters, magnitude comparators. These things we are going to discuss. And implementation of ROM, PAL, PLD. All these things. Okay. In today's class, we'll focus about the topics, or this as a adders and subtractors. Will focus here. Adders and subtractor. After that, multipliers we'll see. Fine. The last class we have discussed about this thing. All we have discussed in a NAND NOR implementation, XOR gate, all the things we have seen. K-map analysis we did, and 4 variable, up to 4 variable K-map we have seen. SOP we have seen SOP POS form, SOP form, POS form we have discussed. Right. Now let's start our discussion, all of you. Let's start our discussion, all of you. Yes. Combinational logic circuit. Take down, all of you. Combinational logic circuit. What this combinational logic circuit means, what in this case the present output depends on the present input. Remember, in case of a combinational circuits, what you observe here, the present output depends upon the present input only. All of you. And in case of this here, combinational circuits, one most important thing is there is no feedback and there is no clock signal. Feedback and clock is not present, and this feedback and clock, these are present in case of a sequential circuits. Combinational circuits, feedback and clock is not available. Okay, now let's talk about one by one here. The first one is off adder. The first one is off adder. This off adder, here you can see this is my off adder. This off adder contains two inputs, A and B are the two inputs. It will contains two outputs, one is sum, the other one is carry. Two inputs and two outputs. A and B are the inputs, and the sum and carry, these two are the outputs. Now this is the off adder. Now you can tell me this off adder. See this thing, A and B are the inputs. Now let us say both A and B both are 0, 0, 0, 1, 1, 0, 1, 1. All of you copy this note simultaneously. Okay. Now you tell me now here, if we 0 plus 0, what will get now here? Sum 0. There is no carry now. When you add the 0, 0, there is no carry. 0 plus 1, sum is 1, carry, no carry. 1 plus 0, sum is what? 1, there is no carry. And this 1 plus 1, 1 plus 1 is what here? Sum is 0, carry is 1. 1 plus 1, sum is 0, carry is 1. Isn't it? So from this, what we can say, this sum expression, tell me here. The sum expression which is given as, you can tell me the min terms here. What are the min terms for sum here? You can see this is 1 comma 2. All of you, what are the min terms of the sum? 1 comma 2, and which equal to what we can say here. So how we can write this term here, sum expression here? This is A bar B plus what? A B bar, A bar B plus A B bar. And this is, what is this gate? This is nothing but what now here? XOR gate only now. This is nothing but what now here? XOR operation. Next, now let's talk about the carry. Now we'll talk about this carry. Tell me for carry, what are the min terms for carry? Tell me. What is the min term for carry? This is the min term for carry now, all of you. So this is the min term number 1, 1. 1, 1 means what now here? Which is equal to 3. So how we can write the 3 is a, which is equal to what now here? AB. How we can write the 3 is a AB. All of you, this thing. This is a off adder logic we have seen. All of you copied now? Yes. You copy the notes now here. After completion of the class, you simply download this file. If you can download this file, you can keep this file. Okay? You will keep this file. I will share in the group. I will share this thing. Okay, you don't worry. I will share this file. I will share. Next, now let us see the logic circuit. Yes, you try to roughly prepare these notes and listen carefully. So this is, you can download the file, you can download after the class. What is the sum expression is a XOR B. Some expression is what here? A XOR B. And the carry expression is what? What a carry expression is what here? AB. AB is a carry expression. So how we can implement this sum and carry, you can see here. Now you can see here, I am taking the A and B, I have taken here like this. Now I'm calling this as A and this I'm calling as B. Right. Sum means A XOR B. So what I can do from A and from this B, I have taken two lines I have taken here, and the two connections we are making here. I have taken one XOR gate we have implemented like this. Here what I will get now, sum I will get now here, and how will get the carry? A into B. This is A and this is B. So A into B. This is the A into B and this is the carry. And get now here. Like this we can implement here. So here this thing here inside this box, inside this off adder, what the connections are? This arrangement is there. This arrangement is there inside. Next, now let us see how we can implement the off adder using NAND gates. The off adder using NAND gates, sum expression is what we have seen. Sum is equal to what? A XOR B. Sum is equal to A XOR B, and carry expression is what? Which is equal to A into B. We need to implement by using NAND gates. As we have seen, XOR gate, implementation of XOR gate by using NAND gates we have seen. How many NAND gates required? Remember, implementation of XOR gate by using NAND gates. Our diamond symbol. Remember the diamond symbol? Remember the diamond symbol? Right. So we collect the diamond symbol. So this is a one NAND gate I have taken. Here is one NAND gate. And this is another NAND gate I have taken. And here is one NAND gate. This is the XOR implementation we have seen now. This is a XOR implementation. Remember this thing I told, blindly remember this thing here. This is a diamond symbol you can call. So here what we'll get now, this is A XOR B you will get. Diamond symbol. A XOR B, this is nothing but what now here? Sum. This is nothing but what? Sum only. Now we need carry. Carry means what now? AB. So this is A into B. Here what I will get now? Here it is AB whole bar. This is what? AB whole bar. If this is AB whole bar, I need AB. Means what I can do here? So this thing, if I drag this thing here, if I connect this to a one more NOT gate, one more NOT gate means one more NAND gate I can say. Then what I will get now, this is AB bar whole bar. This is nothing but AB only now. AB means this is nothing but carry. All of you. Over. Right. क्या हुआ है? Completed now here. Like this we can implement now. This is the off adder using which gates? NAND gates. This is the implementation of this off adder using NAND gates. So whenever we have the XOR gate, remember the diamond symbol. So this diamond symbol we use so many times. So try to remember the diamond symbol. XOR gate by using NAND gates or NOR gate means diamond. Here we have a NAND gate. Here we have a NAND gate. DAD gate, NAND gate. This is a diamond. Remember the diamond always. Okay, diamond we required. Now let us see this off adder using NOR gates. Off adder using NOR gate. Simply you can implement this thing as by using NOR diamond. Simply NOR diamond. See what we'll get. Implement the, we have seen XOR gate by using NOR gate we have seen, isn't it? Tell me. So implement simply a NOR diamond simply. With the NOR gates, implement the diamond again. Like earlier we have seen, implement the NOR gate by using diamond by using NOR gates. Yes, now this is EAB. This is a NOR diamond. By using this NOR gate, this NOR diamond here, what will get now here? A X NOR B you will get here. But what we required now XR. So what I can do here, I will do one more NOR gate, I will add here. Then I will get it as XR. This is A XR B will get. This A XR B, which is nothing but sum only. That is a sum. Okay. Now we need carry also. Where will we get the carry? You can see. Look at now here. This is here. What we'll get now? A plus B whole bar means this is A bar into B bar, isn't it? Here this is A bar into B bar. This is A. You can see this thing. What we'll get here? Here what we'll get now here? A plus, yes, A bar into B bar whole bar now here. This is a NOR gate operation, isn't it? So you tell me this thing. Let's simplify this thing here. So this is, yes, distribution property. This here we can apply to A bar and B also. This we can write it as what now here? A plus A bar, yes, into A plus B bar whole bar is there. So this is nothing but what now here? A plus B bar whole bar only. So what I will get now? This is nothing but A bar into B. Yes or no? Now here what is now? Similarly, what we can write now here? This is nothing but A into B bar. I can write A into B bar. So here what I will get now? Here it is a, this is A bar B plus A B bar whole bar, isn't it? This means what here? A XOR B whole bar na, that is X NOR. That's why it will becomes what now here? X NOR A X NOR B. So if you take one more NOR gate, it will becomes XR na again. It will becomes XR, isn't it? Now we'll see this thing here. Where will get this as a? Where will get this as a? And gate. That means carry we required now here. Tell me how I can get this carry. Tell me. Can you tell me where you can get this carry? So for carry, we required what now here? Simply A into B is required. Where we will get A into B? Here we will get A bar into B bar. isn't it? So here, what is this thing here? This is this is B. This is A bar into B bar, isn't it? So if we multiply these two here, what we'll get now? This is A bar into B bar plus B whole bar now here. So this is, which is equal to what we can say here? This is B plus A bar into what now here? B plus B bar whole bar, and which is equal to what we can say here? B plus A bar whole bar, which is nothing but what we can say here? B bar into A. Isn't it? That what we have seen now? All of you. Yes. Now, where we can get this as A into B? Some we should get now here. Where we'll get the this as carry here A into B? This is AB required now here. This is A plus A bar whole bar if we do this thing here. So this is what we'll get now here. A plus क्या हुआ है? We are not getting. We will get A plus B, A into B. We got the carry now here. Let me think this thing here. Tell me where we will get this as AB carry. Tell me where we will get is what we can do. This is not get now here. Try it. Where we will get A into B. From here only we should try it now here. Check it here. Check it once again, all of you. You people here will get this as AB. This is A plus B whole bar. We get A plus B only now, but we need what now here it is a if you correct one more NOR gate, that will be again extra gates will get extra gates. No, I think so. With this 5, we should try to implement it. With these 5 gates only, we should try to implement it. A bar plus B bar whole bar. Where we have A bar plus B bar? We don't have A bar plus B bar. We don't have now here. We don't have A bar plus B bar. We have A bar into B bar. We have now. We don't have A bar plus B bar, isn't it? Sochiye. Think about this thing here. Oh yeah, okay, we're not getting this thing here. Mm-hmm. Mm-hmm. We need AB required. Hmm. How to get AB? Mm-hmm. Nowhere it is not. Here it is A bar B. Here this is A bar B. Here this is AB bar. Mm-hmm. AB. What we can get now is. Mm-hmm. Yeah, क्या वो है? Mm-hmm. Whether you got it or not. Yes. Any of you? Try it once. Mm. Yes. Fine. Okay. So from this, what we can do here? Okay. So we did this thing. We got the okay. Understood this thing here. The problem. Yes. So here it is not possible to get AB now. Yeah, this is not possible to get AB, right? So let's try the some other method. Here this is not possible to get here. So if you want to get this is what we should do here. Simply here we should take this is A and B. I am taking this as yes. This is A and this is B. A, this is B, and these two are connected to a one more NOR gate. You can see this thing. What you will get? This is A bar. This is the B bar. This is A bar plus B bar whole bar. This is nothing but AB. This thing we will get now. But here you can see how many NOR gates required to implement this thing. Yes, this is the 5 plus 3. Total is 8 gates are required. How many gates we require here? 8 gates are required. This is the thing by using this thing if you want to implement this thing here. So that's why we don't prefer this thing. We always try to implement the minimum number of NOR gates. So let us see the some other technique here. How we can implement this thing. Some other technique what we are doing is yes, this is my NOR gate. Understood the previous one, so it is not possible to implement a carry. Both we required. That is next what we are doing is let us try to get the H of the both one here. A and this is B bar. This is A, this is B. Now here let's get the carry here. Here we'll get a carry. This is what now it is AB now. This is AB, all of you. Next, what I'm doing is and these two are applying to a one more NOR gate. Now this is AB. This is what we'll get now here. A bar plus B bar whole bar, isn't it? I'm applying to this is one more NOR gate we applied here like this. Okay, now here what we'll get here? This is nothing but AB now here. So I can say this is the carry, this is a carry, isn't it? Now you can tell me here what we'll get now. This is what here? A plus B whole bar. Here this is AB, isn't it? Now what we'll get here? A bar into B bar plus This is what? A bar into B bar plus what it is? AB. Look at now. A bar into B bar plus AB. What this is? A bar into B bar plus AB. This is nothing but what it is? A X NOR B. This is the A X NOR B operation now. But we need XR. XR case, what I can do here? So I will connect one more NOR gate. Then I will get AXRB is possible or not. This AXRB, this is nothing but sum only. And here we will get AB. This is the carry. All of you. Now, how many NOR gates are required in this case? You tell me. 5 is sufficient now here. How many NOR gates here by using this method? 5 is sufficient. But if you want to implement this thing by using here, 8 gates are required. So we always see the minimum number of gates we should talk. So that's the reason we'll prefer this logic instead of this logic. Okay. Okay, all of you done? Chalo. Yes. Next one, of subtractor. Of subtractor. Of subtractor also we have a two inputs. We have A and B are the two inputs we have. One is a difference, the other one is a borrow. One is a difference, the other one is a borrow. Two outputs are there. So tell me the combinations now here. 0, 0, 0, 1, 1, 0, 1, 1 I am taking here. Now tell me the difference now here. 0 minus 0, 0. Here the subtraction means we are doing this operation. A minus B I am doing. Remember. What the operation I am doing? A minus B. 0, 0. And borrow 0, 0, 1. 0 minus 1 means what now here? Difference is 1. Borrow is 1. And 1 minus 0. Yes, the difference is 1. Borrow 0. 1, 1. So the difference is 0. Borrow 0. So tell me the min terms here. So what is for the difference here? So here the difference which is given as what now in terms of sigma 1 comma 2. That means what here it is a, so this is A bar B plus AB bar. This means this is also nothing but XOR operation only na. And this is borrow. And for borrow, what are the min terms here? We can see min terms are 1. So this means what here it is a bar B. Min term, this is 1 A bar B. Right. And we can implement this thing. Here we have seen the difference. What the difference is a, which is equal to XOR operation. Difference is XOR operation, and this borrow. And this borrow is what? A bar B. So what I can do here, same manner, I'm taking this is my A and this is my B. And these two we have taken as like this. I have taken one XOR gate here. I have taken one XOR gate. Yes, here this is A XOR B. This is nothing but what here it is a difference. Next, A bar B. This is A, this is B. A bar B means I can take one NOT gate is required now here for A bar and then NOT and gate here. This is what here it is a bar B and this is called as a borrow. This is called as a borrow, isn't it? Like this we can implement it. Now let us see this off adder and this off subtractor. How we can implement single circuit should work like a both off adder as well as off subtractor. So what I'm doing is, for off adder case, yes, A XOR B, Subtractor case also A XOR B only now summon difference. Here what we require now A B. Here we required what now? Here it is A bar B required, isn't it? A B and A bar B. Now let's see this thing, how we can implement this thing. Yes, I have taken this is my A if I say, and this is my B. Now you can see here, this is, I'm calling, this is A and this is B. Okay. Now this is XOR gate I have taken. XOR gate I have taken. Here we can get A XOR B. Now here sum or difference is both are same. Sum and difference will get A XOR B will get, isn't it? Next, we require this as a, here a carry will be AB. Here it is a bar will be A bar B. How to get this thing here? For this purpose, what I am doing is I am doing some special arrangement I did. I did some special arrangement I did. What I did is I have taken one XOR gate, I have taken here like this. I have taken one XOR gate like this. And this XOR gate is connected here like this. XOR gate we have connected here. And this one of the input we have taken, this is my control. This I am calling as what? Control. Right. Now I have given the connections like this. Now this is the AND gate. Now here you see this thing, what we'll get. Look at now here. If if the control equal to 0, what happens here? This XOR gate now here, if one of the input is 0, how the XOR gate will behave as a buffer or inverter? If the control equal to 0, then what now here? XOR gate. So this is the XOR gate here like this. Yes, this is A, and one input we have taken this as a control. If the control equal to 0, it will behave like a buffer A. If it behaves like a buffer, you tell me this is now here. What will get it is now A, and this is B. Then what I will get now? This is AB. I will get now here. I will get AB. If it is AB means this is what now here? Which case we have AB, we have off adder. Then this will work like a off adder. Then it will work like a off adder, I can say, all of you. Isn't it? If the control equal to 1, if the control equal to 1, then what happens now here? So if one of the input for XOR gate is 1, then XOR gate will behave as what? Inverter. This is the control. This is a control. It will behave like inverter. This is A bar, isn't it? If it is A bar, now you tell me what will get now. This is A bar. This A bar B will get now. Then this is what now here? Off subtractor. In that case, this is what? Off subtractor. Everybody. Isn't it? So now the single circuit should work like both off adder as well as off subtractor according to this control. This control is like we can imagine like a shift operator. Control is like what we can say shift operator. All of you done? Everybody. Chalo. So now let's see the next one. Next, we'll see this as a full adder. Full adder. It is full adder. Full adder will have how many inputs it contains? 3 inputs it has, and 2 outputs. Sum and carry. Sum and carry. And let us see the all the possible combinations now here. Yes, 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Okay, these are the inputs. Now tell me the sum. If we add all, this is 0 carry 0, sum 1 carry 0, sum 1 carry 0. Add now 0 plus 1 1, 1 plus 1, sum 0 carry 1. Yes, if we add this in 0 1, what will get now? 1. 1 and 1, what will get now? 1 plus 1, this is 0. This is the carry now here. Sum is what? 0 carry is 1. Add 2 2 like this. This is zeros. So sorry. Sum is what now here? Sum is 1 carry 0. And this is what now here? 0 1 plus 0. Sum is 1. So 1 1. Again sum 0 carry 1. So sum 0 carry 1. Sum 1 carry 1. All of you. So this table, everybody completed this table. Understood the tables now here? Now tell me here some expression. Tell me the sum here. So the sum in terms of what we have it is a sigma m of what here? 1 2 4 7. Sum expression is 1 2 4 7. Carry min terms are what here? Carry min terms are what we have it is a yes 3 5 6 7. 3 5 6 7, isn't it? 3 5 6 7. Now we can see these expressions now here. Now what will get the sum expression, you tell me, for full adder? So what are the min terms we have seen? This is 1 2 4 7, 1 2 4 7, isn't it? Yes, 1 2 4 7. Let's try to minimize these expressions. Let us try to minimize this expression by using what now here? K-map. Now for minimization we use a K-map. K-map, use the K-maps. So now let us say this is A and this is BC 0. Yes, so this is what now here? A bar A now. This is B bar C bar. This is B bar C. This is BC and BC bar. Tell me the min terms now. What they given here? It is a 1 2 4 7. Is it possible to minimize this thing? No. This thing, so there is no grouping is possible now here. The grouping is not at all possible. If possible, we can group it. If this is not possible now here, so directly we can write the sum expression as it is. Tell me sum expression is A. 1 means what we can say here? A bar B bar C. 2. Yes, what we can say here? A bar B C bar. 4. A B C bar. No. 7. A B C. 7 means what now here? A B C. This is the sum expression. Now what I'm doing is here so this is ABC, here it is A bar B. So here what I'm doing is now I'm taking a C common here in this and this. If I take C common, what I will get? C bar common, what we have it is a this is A bar B plus what? A B bar, isn't it? Plus here also what we can do here? A B plus A bar B bar into C, isn't it? Yes, so here this thing you can remember this as what now this operation is a, this is C bar into, this is nothing but what here, A XOR B, this is A XOR B, SR now. And whatever this is a, whatever this is a, A X NOR B, isn't it? A X NOR B into C, A X NOR B into C. So this means what we can write it as a, so this is finally some expression I can write it as, this is A XOR B into C bar plus A XOR B whole bar into C, isn't it? XOR means XOR complement. Now you tell me, basically if we have E and B, if we have two inputs are there, tell me what the expression, some expression you tell me. Let us consider we have two terms we have, let us say here, let us consider here PQ, we have two terms, let us consider. Can you tell me the sum expression? Can you tell me the sum expression? What we can say here, this is what we can say here, P bar Q plus what we can say, PQ bar, isn't it? This seems to be like this now here, this equation here, this is A XOR B bar into C plus what here, A XOR B into C bar, isn't it? Here you can treat this as a P is equal to A XOR B, isn't it? P is equal to A XOR B and Q is equal to C. Q equal to C. Is this thing? Is this the expression? All of you? Right. This done like this. Now let's talk about carry. Whatever the carry we got, whatever the carry we got, carry which we got it as what now here, sigma m, what here, 3567, 3567, this is the carry. Now this is, try to minimize these terms here. So what is the expression here we have, this if we expand it now, 3 means what here, A bar B C, 5 means what, A B bar C, and 6 means what, A B C bar, and 7 means what, A B C. Now if we group these two here, what I will get now here, it is a, if I group these two, what I will get now, this is AB. Now if I group these two, what will get now here, it is a AC. If I group these two, what I will get now, this is the BC now, all of you. So this is the sum, sorry, this is the carry expression is what we can say finally, AB plus BC plus CA, AB plus BC plus CA. Yes, and I will modify this carry another form as we did this thing now here. So let us try to minimize this thing some other different manner, I will tell you. So which is equal to here. And what I am doing is, in these two, can I take C common here? In these two, if I take C common, what I will get now here, it is A bar B plus what here, A B bar into C, isn't it? plus. If I take C common here, what I will get now? This is AB. Now you tell me this is. This is nothing but what we can say. This is AB plus what here? A XR B. A XR B into C. AB plus A XR B into C. This is the carry. So we can try to remember this both carries. Sometimes we use this thing, sometimes we use this thing. Right? Now, here, finally, if we got here, see the things now what we have implemented now here is a sum expression. Yes, what is the sum expression we have seen? Tell me here. A XR B, yes, whole bar into C plus what? A XR B into C bar, isn't it? And the what the carry expression, which is equal to AB plus what? A XR B into C, isn't it? Now let's see how we can implement this as a full adder by using two off adders. Full adder by using two off adders. Consider here I have taken one off adder I have taken. This is what? This is one off adder. This off adder will have a two inputs, isn't it? And it has a two outputs. It has two outputs. Now consider here this is something P, consider this is C. Now this expression, this I'm calling, we get a sum, will get now here we'll get a carry. Now can you tell me what I will get here? For the sum expression means what? I have given two inputs we have given, that is P and C. What is the sum expression of this off adder? This is what here? P XOR with C. Yes sir, no. This is the sum expression. And what the carry expression is a P into C expression na carry. So the off adder, whatever you have given the inputs, here will get as XOR operation. Here it is a what now here? AND operation. It doesn't know what we have given the inputs. Whatever you have given inputs, it will do this operation. Fine, all of you? This thing. Now, what I am doing is I am taking one more off adder I have taken. This is another off adder I have taken. This also will have a two inputs and the two outputs it contains now. Two inputs and two outputs. Let us say this input I am calling as AB, and yes, here this is what here sum of this off adder. This is a carry of this off adder. Right? Now you tell me this is. What is the sum I will get here? What is the sum expression? Here this is. A XOR B, now sum expression means what here? A XOR B. And what a carry expression here? This is what now it is A into B is a carry expression. All of you. This thing you understood now here. Now what I am doing is I am doing this connection I did like this. This connection I made like this. If I did like this, let us consider. Then what happens now? Now this P is nothing but what now here? A XOR B. This is the input for this off adder now. This is A XOR B. Yes or no? I did this connection I did. Everybody. Now what I will get this is. What is this? P. P means what here? A XOR B XOR C only na? Yes or no? In place of P, I should place it as A XOR B XOR C. Next here what I will get now, P into C means what it is, a XR B, A XR B into C, isn't it? Now what I am doing is this thing and this thing I have taken like this, and these two are connected to a R gate. These two are I have connected to a which gate is a R gate, like this I have connected. Now you tell me what I will get. If I connect this is here, this one input is what now, AB, and this is the other input now here. Then at this location what I will get? What the output of my R gate is now here? This is AB plus what? A XR B, A XR B into C, isn't it? So this is A XR B XR C. This is nothing but what now here, some expression or not? This is the sum expression, and this is what now? This is a carry expression or not? So this is nothing but carry. So here this is the implementation of a full adder by using what? These are the expressions of what? Full adder na? Here you see we have implemented the full adder by using two off adder. This is off adder 1, this is off adder 2. This is the implementation of a full adder by using two off adders. Implementation of full adder by using two off adders. Done, all of you. This is the implementation of off adder by using full adder by using two off adders, isn't it? Like this we have implemented this thing. Full adder with the two off adders, isn't it? So here even we can take the two off adders, we can implement it is. So here this is my one off adder I have taken. This is A and this is B. If I did this thing here, here what I will get now here, AXRB. Here this is what now here, AB, isn't it? This is the off adder. This is the off adder. This is one off adder. Next, so here we have taken, this is one more off adder we have taken like this. One more off adder we have taken like this. Yes, one input is new input C, and here the previous input they has connected like this, isn't it? Now here what I will get now here, A XR B XR C, isn't it? Now here this here the connections are made like this. These are the connections I made like this. Yes, and here what I will get now here, A XR B into C, isn't it? Now what I did now here, this carry, I've taken this is a carry and this is the another carry, and these two carries are connected to one R gate like this. Here we'll get the final carry we'll get, and here this is the sum, final sum we'll get. Yes, isn't it? Now you can see here. Yes, here this is one off adder and this is the another off adder. By joining these two, we can get what now here the whole thing is a full adder. Now this is the implementation of full adder by using two off adders. Like that we can implement it. Fine. Done. Fine. Yeah, that's for today's class. In the next class, we'll see the remaining of subtractor and then multiplexer, demultiplexers we'll discuss. Okay.